Okay. I probably should make some announcement first before we went over today's topic. So you probably got my notification. So our homework 5 and homework 6, they're both the deadline both get extended a little bit. I actually appreciate, especially those who came to my office hour for the past few days. There are some issue which I think you're struggling not because of object-oriented programming. It's more about how to create one single makefile and then have multiple programs and compile with different flags. That's actually not that easy if you are not very sophisticated about the detail about makefile. So I feel it's good for you to actually learn that part of the programming development with makefile and see the difference. I think that's good. So that's why I feel it's fair for you to actually have a more time to be able to finish that and then also get to learn about those in detail. But that says that kind of push our time window extremely small in terms of our homework assignment number 7. So what I will do is that I'm actually going to make some adjustment about homework assignment number 7. I'm going to tell you some element about homework assignment number 7 today, but it's more likely, it's not, I haven't exactly figured out the term, but it's more likely we will not have a kind of homework assignment number 7 that's actually mandate for all of you. If you're interested to, some of you I know, you already finished homework 5, homework 6, you can actually still working on homework 7, which I feel is very interesting. But it will not add you anything to your grade or something like that. It's just for you to learn something more about. I mean, I like homework assignment number 7. It's essentially include almost every single element we have learned in this class and kind of put together as one single homework assignment. But nevertheless, the content of homework assignment number 7 means that the lecture I'm going to provide for the next few, whatever, maybe only 2 weeks left or less than 2 weeks, it will be the concept will still be included in the final exam. I will figure out exactly how to weight it, like the credit and things like that. But essentially, we will not have homework assignment number 7, but officially, but you can still working on that. We'll release, and the thing is that the concept will be also tested in the final exam, which means that you still have to come to the class or follow the lecture until the end of the quarter, okay? All right, so having said that, so we talk about 2 concepts. One is the function template, one is a pointer, and then we see that how we can parameterize and then to get some code looks very powerful. And the other thing which I want to go over very quickly is called lambda expression, which is happen to be a subject on the chapter 9 of our textbook. So what is a lambda expression is, you can think about it as a function, but without name. So I will just show you some example. What is a lambda expression? For example, this is a lambda expression. And you can see that this part of code looks exactly the same like our example before, but you see that I don't have any name of the function. But what I do is something we call lambda introducer. If you see something as a after equal sign, you see a pair of brackets, and sometimes there's nothing in the bracket. Sometimes there's some character in the bracket, like equal sign, which meaning that there's some meaning of the function we try to define. And after this lambda introducer, the first part between this parenthesis, or actually I say between this dash greater than, the arrow before that is the is the argument. So basically, essentially, before this arrow is the argument and the argument type. And after this is the return type. Okay, and then after the return type, you essentially has a pair of bracket, curly bracket this time, which include all the function body. So in some sense, it's like a function, but I just declare this way. So this is become a, because for example, I want to deal with a function pointer to a function, like we talked about last time. I sometimes just don't want to have a name because I want to actually express it this way, and then such that I can pass it as a parameter. For example, IR may be a parameter to something else, which means that almost like a function pointer, but it's really a function. And then after you define this nameless function, you actually assign that to IR as a variable, then you can just call that function and using IR 35.0, for example. Okay, so here is another example. To use this example to tell. By the way, this is the syntax for a lambda expression. Is an introducer, argument, and then return type and the body, basically. Okay, now you can actually write no, not this one. This one, yeah. I can actually do it this way. I kind of modified the code from the last time. So essentially, I have a function pointer, and this function pointer declare like what we did last time. And then I basically just say this function pointer, I assign a lambda expression this way. So essentially it's pointing there, so then I can call it. And also, let me see, I have an example which I can use. You see that I sometimes can actually make a function looks like this. I make a function, okay, this is actually an interesting example. It essentially includes template, the function template and the lambda expression together. So the way it works is that I still define this template is in range, just like this way. But the second argument is actually a lambda expression type. So when I declare I said, well, you can actually declare this way, but I'm going to return my lambda to the argument value. So when I actually call the function template, look at what I did. I essentially say is in range, and then inside here, I just basically put in a lambda expression looks like this, and then it will be passed into the template, and then it will ask you exactly the way it works. So instead of finding the function, so instead of just have the flexibility to change the type, you can actually have the flexibility to change the function itself, the logic, the algorithm, using lambda expression. Okay. Okay, that's pretty much I want to talk about lambda introducer. So before I go to the topic, any question, by the way? Yes, please.
The function, like in this case, like statically allocated during runtime, but like functions, if you just define a regular function, it's like hard coded into the program. Is that like a difference?
In fact, lambda expression, the function is also compiled at the compiler time. So in fact, this is not a runtime. So, okay. So I should probably say this. So when you have a lambda expression, let me go back to this example. When you have the like this way, right? So you can see that here is a declaration or definition for lambda function, and then this is a function pointer. So basically, the compiler already compiled this part of the code that I just highlighted over here already into a binary code. So this compiler already compiled this code. This is, by the way, is different from what we call interpreter. Interpreter means that at runtime, you start to understand the programming language, the high-level language, and try to see what it is. But this is still compiler concept. It's just compile, but then they will assign the function pointer. It's in my opinion, it's just a way for you to, a different way for you to utilize something like a function pointer.
So just like nameless. Just
Right, just nameless. So that's why I feel it's nice, but not necessarily I need to use it, to be honest with you. Yeah. Like a function pointer, I can argue I want to use it, but lambda expression, strictly speaking, is just another way of representing a piece of code. Okay. Any other question? Yes, in the back. I don't have to. I don't have to. For example, in this case, I actually assign, right, to a function pointer. But in this case, you can see that I actually directly put the whole lambda as one of the argument. You see that I have the argument 30.0, and then this, the whole thing is a lambda. I just basically, the program looks a little bit ugly, in my opinion, not very readable, because you suddenly you see the whole code is actually inside one of the argument of the function. Yeah. No, you don't have to. You just basically assign the whole thing. And because it's a lambda introducer, compiler no, it's a function pointer. Compiler will treat it as a function pointer, but compile that code, arrange it in some area. Yeah, that's a good question. Yeah. Yes.
Are you still able to handle like feeding lambda expressions into other lambda expressions? Like you can,
Ooh,
like this, or...
that's interesting. That's interesting. I think in theory, yes, we can do that. But in practice, I haven't seen too much of a good example in my mind. In fact, to be honest with you, I never use lambda expression, because I mean that could be because I don't have a feeling toward this concept. So it's not saying the concept is not good. It's just I don't have a good feeling. Just like multiple inheritance. Oh, multiple inheritance. I did use that, and I crashed myself. So that's different. Yeah. Okay. Yeah, but that's a good point. Yeah, to have a lambda within another lambda, I think it's definitely doable, right? I just want to have a multiple layer of this kind of concept. Okay. Yes, please.
What would the benefits be to formatting? I don't know, arguments not.
Right. Yeah, it's a readability issue, right? It's a readability. I actually feel that it's a little bit odd, but just look at this. Usually when we read a function, it's usually the first thing we read is a return type, and then we look at the argument. But the lambda expression is first is the argument, and then return type. That part is already a bit kind of different from the normal function. So I feel for readability is really a challenge for those of us who never or hardly ever use the lambda expression. I mean, this is by the textbook. When people talk about using lambda expression, they always say it's good to passing a function or some kind of body of code inside the argument. Like this case, like this kind of case is actually one of the things they feel is good. So you put in that. But in my opinion, if I'm doing this, I would rather to move that piece of code somewhere else and assign to a function pointer and then put a function pointer over there. Because if you look at this piece of code, it's actually not trivial for you to parse. I mean, I have to know that, oh, from this parenthesis correspond to which parenthesis? Actually, this parenthesis. Oh, sorry, the second one. The second one from the last. It's just try to parsing it visually. Sometimes we make a mistake, understand. Yeah. So I'm not sure. I mean, a lot of the idea in programming language is kind of flashy. I will use the word, but not necessarily helping us very much. Yeah. Okay. All right. Good. All right. So I'm going to just show you one example about function. Oh, wait a minute. Where's my code? All right. I thought I have a slide. Okay, forget it. I'll use the source code to show you, and then we will go into the next topic I want to tell you. So you have been using a template called vector, right? You have using a template called vector. We're going to talk about some other STD. So I'm actually going to give you an example that I'm actually creating a template like a vector. I call it template array, to just tell you that how you can actually write a template class. So I'm actually going to declare a template I call array. So I have two things. One, I have to how do I actually declare a class template? That's number one. Number two, I want to say, well, how do I actually be able to really instantiate that particular class template to a particular class I would like to handle? So if you understand this, then you understand when we talk about things like a map or vector, they are basically doing exactly the same thing. So first, let's see, how do I actually define that? So essentially, you have a template. We're going to do a template, but then the template, just like template function, I have that between that whatever bracket, it has parameterized about some of the type name, and then I can actually start to say class array. So the template, the array, is the name of the template, not the class. Okay, so this is basically a class template. So I call a vector. And inside vector, you can see that I actually have some kind of data. I mean, it's very simple. It's T star is a pointer, and the T is going to be whatever the type name you have. And then within here, I have the constructor, and then I have the other function you want to have. Okay, so by looking at from here to here, that you realize this is something which usually we put it in the .h file. And in the .h file, when you fix the type T and you replace that, that becomes whatever the instantiation of the real class that you want to use. Now we have T. So that's why you can actually do an array of integer or an array of whatever object, like a thing or person. Okay, so that's how you declare. Yeah.
You said array is the name of the template, not the name of the class, right?
Yes.
So why we have the array constructor? I mean, the name of the constructor should be the name of the class.
Right. So that is also if you look at this part, this is actually the constructor template. So not only I have the template for the class definition for .h, but also have a class template for the .cpp file, which is a constructor or whatever. You can see that over here, this is a constructor, right? So when we declare the constructor in our .h file, we do not put the name of the whatever the class name. Oh, I see what you're saying. You say, well, I'm using the template class array instead of the class name, right? So when you are using it, they will actually create a class which with a constructor that will match whatever eventually you have. Okay. So this might help you. If you look at this part, now this part is how do I actually declare the constructor of the template. So it's really not a constructor, it's a constructor template. Once you have that type name, so you can see that again, I have a template, and again, I have to declare the introducer. Basically, you have to set the T, and then you say array, the type. Now you see that the array type is array, and with a T, because the type going in, and then the second part is actually array. And then with the argument over here matching this one, and then you basically generate the code looks like this. Okay, so that is the, and then we just look at, let me see, look at, this is the function. This is function. This is actually a template to the member function of that template. Okay, so you can see that it's the same thing with the type name and blah, 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 like this. Okay, Any question? Okay, so now let's actually take a look. How do I actually use this template? And just look at the template has two parameters. One is basically some kind of array and some kind of integer s. So essentially, this is the way I actually use the template. So basically, I say array and then integer. That means this is going to be instantiation. Once I provide that capital T, is going to be replaced by the type integer. And when I have done that, then essentially, I actually can say a array 5. This is essentially declare a object that's going to create under this instantiation of the template. So I create object A, which is the array of integer, and then I call the constructor this one. Okay, so then this is the mechanism. So everything here is done at the compiler time. Okay, it's not runtime. At compiler time, I actually need to figure out all of this. So you can actually think about that. The compiler is based on this input integer here, and based on all this template specification above, the compiler is actually going to generate a piece of code. So this is totally a compiler concept, and it will generate a piece of code, and then it will try to compile. If you have any syntax error, it will be detected at the compiler time. Does that make sense? Because this thing, you shouldn't do it at the runtime. Everything has to be in compiler time. If you have a polymorphism, it should be reflected at the instantiation of the template. You can have anything you want with a C++ mechanism we touched this quarter, and the compiler basically use the template, whatever, to generate the code, and then they will run through a rigorous check. The whatever C++ is checking, they're going to check if you have an error warning message, it will come up through that process. Okay. Okay. All right. I have about 22 minutes. Now I want to do something which is kind of, I would say this is kind of fun, actually. I want to ask you a question. How many of you here have never used ChatGPT? Okay, some of you never used ChatGPT. Okay, you don't worry about my next question. My next question is to all of you. For the rest of you, have you ever doing programming? Like using the OpenAI's ChatGPT API? Any of you? Have you heard about that? Okay, never. Oh, you heard about that. Okay, so if you're going to write a program to interact with OpenAI's ChatGPT server, what language do you think you will pick? Don't be afraid hurting my feeling, or just be honest. What language? Python. Okay, that's correct answer. Okay, so yes, the most popular way to interact with ChatGPT is actually through Python. You can write a program to do that. But it's also totally available that you can use C++ to do that. Okay, it's the same thing. So let me actually show you a program. No, not here. Okay. This is my version of, by the way, the code that I use here, I have uploaded to the GitHub. You can actually, yes. It's actually easier. Python, for example, Python's interface to JSON is kind of almost like a built-in. And Python is just, you don't need to worry about like unnecessary complexity, like a pointer. That's basically the thing. But to be honest with you, C++ is a harder language to learn, number one. Number two, you can all testify, right? Okay, after this quarter, you can talk to ecs36b student to tell them how proud you are, okay? To learn a few things they never have to worry about. Yeah. Okay, so number two is that, in fact, if you have the right library, then C++ can do exactly the same thing as Python if you have the right library to do that. Okay, so I want to tell you that I give you a very simple test program. Let me actually use a different program. I don't want to spoil the fun immediately. This is actually the program that's actually included in the example about how you can actually using C++. This is released by OpenAI. By the way, this is everything is developed by OpenAI. Okay, so let's actually ask you about this. Okay, I kind of play around this a little bit. If I have a program looks like this, you know what? I want to actually tell you this first about what this program is doing. So the program is very simple. It's really just 3 lines of code. You want to do a GPT or OpenAI. It's really you need to learn 3 lines of code. The first line of code is just set up authentication. OpenAI ::start. That means you can authenticate that you actually have a valid account with OpenAI. That's number 1. Number 2, I'm actually using something called completion. So ChatGPT has multiple servers. And one of the most popular servers is called completion. What do I mean by completion? It means that you actually provide part of the sentence and OpenAI will try to complete the rest of the sentence, which I will show you the example. That's called completion. That's probably the most commonly used service. But they have other services. Christopher, you what is the auto? Oh, okay. Good point. Okay. So I never teach you about auto. Auto is not a ChatGPT thing. Auto is completely a C++ thing. So if you declare something as auto, this typically is on the left-hand side of a assignment. So which means that the compiler is going to look at the right-hand side and automatically figure out what should be the data type for that auto. So for example, that completion, maybe it should be a JSON. But the thing is, on my right-hand side is a JSON. So compiler will automatically assign the type. So that's called auto. By the way, this is a good thing. Christopher, I think you bring out a really good point. By looking at OpenAI's code, you actually learn a few things, which I actually didn't mention earlier. But now looking at the code provided by really good software team, you actually sense that what kind of things you're using. And for example, you will ask question is what is auto? Okay, so let's actually take a look at the second line. The second line, essentially, I sent a completion service to the ChatGPT and get a response. Okay, so you can see that I'm actually calling a function called create. And then create has a bunch of things. You can see that what's the format looks like to you? This is a JSON. Okay, so essentially it's a JSON. I mean, basically, ChatGPT, you're just basically construct the right kind of JSON and send it to the server, and then you have a way to actually look at what it does. Okay, and after the line, you actually try to do that, and then the third line, you can see that I'm trying to print the response. And what's the response? Is just completion.dump. This is not my code. Okay, this is basically the OpenAI's code. So first I want to tell you that OpenAI really have only 2 programs. This is something which you will learn a lot from this code. The first code, let me actually just do a .h. There are 2 .h file. Where am I? HPP. Okay, so they actually use the convention, not .h. They use HPP because in the software development, they try to differentiate whether this is a C include file versus this is a C++ include file. So they kind of have a naming convention. Say one is .h, one is .hpp, which the compiler actually doesn't care. You call it .h, .c, or .d, or .y. Doesn't matter to the compiler. Compiler just treat it as a source code they need to parse. But this is really just for clarification about whether this is C++ or whether this is C. So that's your convention. So you will actually see two HPP files. Let's look at how big they are. So the code OpenAI really provide the core service is really 833 lines of code. If you know this 833 lines of code, essentially you know how to inside out about how you're going to communicate with the ChatGPT server. And let me just tell you that this JSON.h or HPP is a different implementation of JSON. So we're using in the previous, when I talk about JSON value, that is the library called JSON CPP, which is the most popular JSON library. And OpenAI, the developer, decided to use an implementation of the JSON library developed by Niels Holman, and his implementation is actually more efficient. The thing is that the user interface, the perspective are very similar, but this particular version is actually a little bit efficient, not all the case, but a little bit efficient than the JSON CPP. Okay, so basically you should know the other one is JSON is very popular, and sometimes the developer are using different style of JSON. I actually post a link somewhere to show the comparison, just to let you know. Okay, so now let's actually get back what's going on with this code. So I actually have a 3 piece of code. One piece of code, I'm sending the query. Sorry, I started, set up my authentication, and the second line of code just send the query over there. And the third line of code is basically just print out what's the response. So let me actually show you some example about how you can get this done. You know what? I'm going to copy the code to a different code so I can kind of show you the progress. I will call it ecs36b test2.cpp. Okay, I want to ask you a question. Do you think UC Davis has a tennis court? We have a tennis court? Okay, so let's ask ChatGPT, okay? I'm going to remove some of the stuff. Are you sure we have a tennis court? I never played tennis in Davis, okay. I want to remove the other thing, sorry. I removed that part already. No, I'm going to get rid of this part as well. Okay. Okay, now you look at the code. The code is really simple, right? Just a 3 line. The first line is start. The second line is basically send the request. Is basically, you see that in the question, I have a few things. What's the machine learning model? Is text DaVinci 003. That's a model you try to use in the ChatGPT size. And then you ask the question prompt. Prompt means that I actually gave you something, you try to finish. That's what is called completion. And then you basically say, well, what's the maximum token you can have, temperature or something, which I don't want to talk about right now. Okay, and then you got your response. That's it. Okay, okay. Okay, let's try to run it. I thought I already have a compiler line I can use. So by the way, you just need to use what? If you work on homework assignment number 0, is minus L curve. That's the only thing you need to worry about, minus L curve. Okay, and so it's 2. Let's actually go to 2. Okay, I got it compile, and then now I set a.out. out. Okay, so this part is what the request I send over there. This part is a request over here until here. You see that is just a JSON encoding. This is doing something equivalent to JSON RPC. And essentially ask the question, does UC Davis a tennis court? And what's the response? See, I was right. I agree with ChatGPT, okay? UC Davis doesn't have. Yeah. I thought I can buy a lotto today. Okay. Okay. Now we're serious. Okay. Let's see what happened. Oh, okay. Now you're happy, right? Okay. It says UC Davis has several, tennis court located on campus. Okay. So now I'm actually going to add something else. Let me tell you what I'm going to add. I actually have that somewhere. Okay. I actually already pick up the text. Okay. So I'm actually going to include the whole thing. Name for the founder women's athletic of UC Davis, the Maria Well Tennis Center serve. You remember this one, right? That's the thing. So I'm going to copy and paste this one. Things are going to get interesting this way. Yeah. So I'm going to change this. Yeah, I think that's fine. I thought it works. Okay. Oh, so maybe all my experiments wrong because that's spelling. Okay, so now this time you see that it's actually I input some text, right? And I say that this is the whatever athletics, whatever donor, they actually have the center, and then I actually have this. So you see that the output is a little bit different. It's trying to complete the sentence, not just based on his knowledge, but also based on whatever text you provide, right? So now I have this one here. So now I try to be, now it's really interesting. I'm going to change this. I'm going to change this to name for the founder of ecs36b athletics. The polymorphic. Tell me if I pronounce it wrong, okay? Serve as what, the winter shelter. Facility for flunked. ecs36b student in spring 2023. Okay. Is that good? Did I misspell anything? All right. I basically just write down something and I try to run it. What do you think it will tell me? Okay. Okay, it says, yes, UC Davis have a tennis court and it's based on whatever. This is the information. Let me actually just give you another final example because I actually want to show you more, but I want to just tell you this is interesting. Let's say the founder this, and then I said, please answer as a tennis hater, as I don't want people to come to Davis to play tennis. Is that okay? Okay, it's pretty good. It's basically say that this is for winter shelter. It's not for not for getting the information. So there is a lot of things you can actually. By the way, I actually twisted eventually. It's actually Felix Wu donated the center for tennis. You can actually fooling around like this. Okay, but there's one thing I just want to tell you that it's fun. You can actually write the program and then try it out to do a lot of things. But one thing you probably didn't notice is that, have you noticed that I have a file, I have a function called create. Over here, I have a capital R. And then with a double quote with a parenthesis, and then with a parenthesis at the end, double quote, and then with underscore JSON. Have you noticed that? That is actually something I want to tell you about a particular feature in C++. So when in C++, when we try to provide a string, number one, I actually, if you look at this is the whole thing is a JSON. But inside here, there's a lot of double quote. How do I know that this double quote is actually matching with this double quote? I mean, how do you usually, when we have to do that in this kind of situation, we do what we call escape character. We put a backslash double quote, meaning that that double quote is not to be the double quote that try to match up, but that double quote, suppose you can print it. So this one is we call row string literal. Row string literal means that you can actually write a capital R. After you write a capital R in any language, not in C++, and then you put a parenthesis right after the double quote, and you put another parenthesis right before the second double quote. Then essentially everything within this two pair is considered as a row character. So you don't have to worry about escape character and things like that. That's actually very important. The second part, you see that underscore JSON. What does that mean? This is actually the JSON library specific, the one that OpenAI choose. This is called user-defined string literal. User-defined string literal is essentially saying that I want to fit the whole input from that first double quote to until this double quote and fit into this function called underscore JSON. So essentially this line is you actually call a function called underscore JSON, and the input parameter is that whole thing over there. This is called user-defined literal. How do you know that? Come here. So remember I gave you two files. So this is really good. I highly recommend you actually take a look at OpenAI.hpp. It's only 800 lines of code, but you should also spend some time to search through JSON.cpp. I feel this is a nice code that you can actually learn something. So I'm going to do operator, search for operator. One second, I want to, not this one. Where is it? There are too many operators. I will just directly search for JSON. Even more JSON, of course. Where do I find it? I found it immediately. JSON, this one. No, this one. Let me actually try to see if I can get it. I should have actually keep it. I just forgot.
That's line 24430.
Okay. You said 2, 24430. Doesn't have that many lines of code. No, why my actually my Emacs actually frozen. Sorry about that. Give me 1 second. I want to. Oh, okay, okay. It's something I actually searched for the code before and just this afternoon, but then operator, this must be something with operator JSON.
JSON underscore.
Oh, okay, good. Thank you. JSON underscore. JSON. Yes. Yeah, here. I found this already. Sorry. Thank you very much, Nicholas. You can see that this is how they define. They actually define an operator because what we have is double quote. That has been already overloaded with the meaning. And then basically it has a underscore JSON. So this is the place where that piece of code got handled with this is called user defined literal, string literal. And that's how you can actually do it in that piece of code. If you kind of confused when you actually read through that piece of code. Okay. All right. So I will actually tell you more detail on Wednesday. We don't have a class on Monday, right? We don't. Okay. And I will tell you what this is all about related to the rest of things you might want to learn. Okay. Thank you. You all have a good weekend, Memorial Day weekend. Thank you for your hard work. I really appreciate. And just let me know if anything I can help you.